Welcome to Lesson 4 of the A-Level Chemistry Bridging work for Devizes School. This lesson is focusing on standard form. Remember, the point of these lessons is to get everyone's math skills up to a base level before we start in September. So as with the other videos, I'd like to stop at this moment and click on the link below or find the link in the description of the YouTube video and complete the starter quiz. This is similar to one you've done before. We've got a table with some terms missing and is seeing what you already know about converting to and from standard form. Again, the point is just to have a go. So why is standard form important? Well, the point is to easily manage very large or very small numbers, but basically it allows us to not have to write down a ton of zeros in very small or very large numbers. And as we mentioned in our prefixes video, you got a digit number, in this case 8.7, and we've also got the exponential number, just here, which in this time is times 10 to the minus 13. So here are the answers to the questions in the starter quiz, if you want to check what you've done. On the next slide we'll look at how we do the conversions. So in standard form, we've got the power of 10, which shows the number of places the decimal point must be shifted either way to give the number in decimal form or vice versa. It's important to note that the digit number also contains the number of significant figures needed. So very important to look out for that in exam questions, as it was at GCSE. But at A level, you might also be asked to put your answer in to an appropriate number of significant figures. And you've got to look at all the information given and work out what's the appropriate number based on the significant figures in the numbers they've given you for the question. Right, so converting from decimal to standard form. So what you've got to do is look for where the decimal is. So in this case, it's there. And you want to see how far that decimal point is going to shift to create a digit number in the number of significant figures needed. In this case, we're just going for obviously these two. So this decimal point has jumped 1, 2, 3, 4 places to the right. And that tells you it's 10 to the minus 4 because this is obviously a small number, less than 1. Going the other way, again, you look for the decimal point. So even though you can't see it, it is actually there because this obviously could be 328,000 point whatever. And in this case, it's obviously 0.00000, etc. But the decimal point is there. So again, you shift it until you get the decimal point to where you want it to be for the number of significant figures you want. So in this case, we're moving the decimal point until it gets to just before the 3, or just after the 3, sorry. So 1, 2, 3, 4, 5 jumps to get there. And because this number is a large number, bigger than 1, it's 10 to the power 5. So going back the other way, so again, you look for where the decimal point is. Well, most times in the digit number it is just after the first one. And then you go, okay, so minus 4, right? I know that number means it's going to be a number less than 1, so the decimal point must be going this way. So you could write a number of zeros in front of this, as many as you wanted, and then you jump 1, 2, 3, 4 times, or if we look over here, that's where the decimal point was. It's gone 1, 2, 3, 4 times that way. And similar to this one, find the decimal point. Because we know it's to a positive power there, we know we're shifting this way or we're making a large number. So we jump 5. And again, you can write as many zeros as you want there to do your working out and then go, okay, it only went that far, which is this many zeros. But for our example, 3.2. 28 is where we started, so if we go 5, 1, 2, 3, 4, 5 jumps, and that's how you convert back into the decimal. Okay, now understanding it that way is obviously good and understanding what's going on, but for most of you, you will be using your calculator, and most of the standard form you'll be using will be on your calculator. So it's useful to have a look at that. So what I'm going to do I'm going to use an emulator here to show you how you would type these in. I'm using this calculator because this is the one that I use all the time. There's a good chance most of you will now have a much more snazzy calculator than me, but the principle is the same. So to start with, let's see what this, or how we type this calculation into the calculator, and then we will look at some other things we can do to help you if you kind of struggle with standard form. So it's 8.7 times 10 to the minus 4. So I'm going to do 8.7. Then I'm going to press this button here. Then I need the minus and the 4. And the key point is that it's just a number. It looks, I suppose, complicated to the uninitiated in standard form, but it's just a number. It's just a shorthand way of writing a number. And then we're going to multiply it by 3.28, 3.28 times 10 to the 5. So exp 5, press equals. And this calculator always comes out as a fraction. I suppose you could change that somehow if you wanted. And there we go. We got 285.36. or what's in this value. Now, if your particular question asks you in standard form, now obviously you'd have to do what we did and go, okay, so I need to move my decimal point 1-2 spaces that way. It's gone to the left, making it's a bigger number than 1, then be a 2. So you could do that. But we're using the calculator right now. So what you can do is go for Shift, Setup, and put it into number 7, SI mode. And then this bit is to choose the number of decimal places you want, and and that tells you where it rounds up. So for this example, we're gonna have to go for 3. And if I press that again, there we go. It shows you it's in its standard form. Okay, so you can put it in this SI mode to help you do any conversion if you're not sure. So if you're in a maths lesson, for example, and you're asked to change it, but you just want to check if you've done it correctly, you can do this. So again, if we do this now, we're still in the SI mode now. So if we go 0.00087, press equals, press that, then it's already in standard form. That's in science mode. Then let's do the other one we did earlier. 328,000, and then press equals. Automatically goes into the correct standard form. Now to go back, so let's leave it in this one for now. If you go Shift, mode, normal. So this is if you want to go back the other way, if you're stuck in science mode and you want it to go back to a normal mode. But also it's a way of converting, well, I'm in science mode and I've got my standard form, but what actual number is it if you need to check that. And then we're going to go version 2 of this. I'll explain what that is in a minute. And there we are. It converts it back to the normal number, and you've got that number there. So just to show you what the different versions of normal are, or normal mode. 1 divided by 200, this is in normal 2 by the way, equals that. It's in the decimal form, so if you're not a fan of standard form, you leave it like that. Now if we leave it like that, so this is in normal 2. If we go Shift, mode, normal 1, look at the value, it puts it in standard form. It basically it sets a range at which it goes into exponential values versus keeping them as a decimal. I tend, if I'm just doing normal calculations, I tend to prefer normal 2, so that's why I'll stick it back in. Okay, so that's how you can swap between different modes on the calculator to check what standard form means. And again, if you're not a massive fan of standard form, it at least gives you an idea of, is this a huge number, is it a small number, what does it mean? But generally you get to a point where you use these numbers so regularly in chemistry calculations that that they just become second nature. Right, so let's do some examples then. So example 1, on July the 14th, on July 1, 2015, the space probe New Horizons passed Pluto after travelling 4.7 times 10 to the 12 meters from Earth. Write down this number in decimal form. Earlier, the space probe flew past Jupiter, which was 5.88 times 10 to the 8 meters from Earth. How many times further did the space probe travel from Earth to Pluto and Earth to Jupiter? So if you pause now, then have a go at this. Maybe try it. Without a calculator and then with a calculator if you like. But again, all of your chemistry exams, you will have a calculator available to you. So I've got no qualms if you go straight for the calculator. Okay, let's have a look. So 4.7 times 10 to the 12, or if you type it into the calculator and do the whole science mode thing, it should come out for you. But again, if we count, that decimal point is moving 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So there we go. Earlier the space probe flew past Jupiter, which was 5.8 times 10 to the 8 meters from Earth. How many times further did the space probe travel from Earth to Pluto than Earth to Jupiter? I do that value divided by that value, and it comes out as that, which is 8,000 times further. Again, if you didn't get the right answer, just go back through it, type into the calculator again, or rewatch the bit earlier where I was typing it in, see if you did anything wrong. Okay, so more of a chemistry example, and then a biology one there. So example 2, 0.125 moles of a particular substance were dissolved in 2.5 decimeters cubed of water. What is the concentration of this substance? Give your answer in standard form. So bit of revision of what the units of concentration are and what concentration is. Example 3, a cross-section of an artery contains 9.2 times 10 to the minus 9 meters cubed of blood. If this blood weighs 7.1 times 10 to the minus 3 grams, calculate the density of the blood, leave your answer in standard form. Alright, so pause again, have another go, and we'll go through in a sec. Alright, so concentration is the number of moles dissolved in a litre or a decimeter or per decimeter of water most of the time. So for this one, you have to do the moles divided by the 2.5, which was already in what it needed to be, which is 0.005. And again, your calculator, if you left it in normal mode, would come out like that. So this answer wanted in standard form. So you convert it or use your calculator to convert it. On this one, so the cross section. So formula, density is mass over volume. So 7.1 times 10 to the 3 mass divided by 9.2 times 10 to the minus 9. 7.72 grams per meter cubed. When I first looked at it, I thought that was huge, but then I remembered a meter cube is actually quite big. So in a whole meter cube, I suppose 7.72 grams isn't much, but my biology knowledge needed me to check that number. Okay, and then you won't be able to answer this at the minute. It was already in the PowerPoint from AQA, so I thought I'd just leave it in as an example. This is all about working out rate of reaction, and you can see you've got initial rate data for different experiments and concentrations, and they're all in standard form. So getting to grips with standard form and understand what it means and the size of the numbers, and being able to decide, right, is that a bigger or a smaller number than that, and maybe converting it into decimal will help you visualize that. Okay, how many zeros is it, that one? Okay, again, the fact that they're the same should tell you they should have the same number of zeros in front of them, so then it just comes down to the numbers themselves. But for whatever reason, standard form can confuse people, and hopefully you've got the tools now to at least work that out so you're not stumped by just looking at them. Okay, as always, there's a worksheet to do and have a go at standard form stuff, so find the link below or in the description of the YouTube video. And then once you've completed it, go back and mark what you've done and see how you do. And once again, another reminder that the GCSE to A-Level transition booklet, which is Excel, but still, like I said, it's still good, is there for you to start whenever you want. That will be your summer task to complete before starting the course at the beginning of year 12. Okay, thank you for watching.